Hey folks, in this video I want to talk about how to actually use ADTs inside of Java. Now most of this is going to be obvious, but we'll talk about it just to make sure we're all on the same page. Alright, so ADTs, you're going to implement them with classes in Java because what else would you do? I can't think of any way off the top of my head that you could do it without using classes. Well, okay, you can do it without using classes, but we'll leave that for another day. Or another course. If you take operations with me someday, I will show you a little bit about how to implement objects in a language that doesn't have support for objects. So there's another way to do it. But anyways, yeah, we're going to use classes basically to implement these things, right? We're going to use classes to implement ADTs, right? And from that, right, we build objects, which are the actual ADTs in our system that do work. All right, so in the language of Java, how do we build ADTs? First thing, of course, is creation. Creation is pretty straightforward. It's the new keyword, right? So you use the new keyword. That gives me a new instance of a class, right? So here I'm building a new linked stack, right? And now I have an object in my system, right? I'm good to go. I can now do stuff with it. All right, what about if I want to use behavior, right? Because ADTs have some behavior associated with them. Well, for that, I need to use the dot operator. The dot operator is just a dot there, put a dot in, and I'm allowed to invoke things, right? So here I'm telling that stack, I want to push the number 5 on you, okay? Pretty straightforward. Now, the last thing here, which I'll highlight, is that in terms of Java, when we do a copy operation, right, we do things like, C2 equals C1, we are copying the reference, right? Because ADTs need to be implemented as classes. So classes, obviously, we create objects from them. Those objects are reference types. Well, that means that when we copy them around, right, using that equal sign, we're just copying the address, right? So this is a little bit, problematic because it means that when we construct ADTs, we'll end up with those issues, right, that kind of come from from the flexibility of references, right? That we can pass around ADT and all of a sudden everybody has the right to change it. So this is a little bit problematic, and that's why we're later in this module we'll actually introduce the idea of an immutable type, right? A type that it can't change. All right, so stuff to know. So question that might have occurred to you is, how is an ADT different from a class? The difference is just abstraction, right? So we had that rule, right, earlier that basically said, okay, ADTs do not expose their internal representation. So again, right, this is our golden rule here, right? When I build an ADT, we want it to be a true black box, right? So the user should have no idea, how the stuff inside works. It should be this pure black box that we have the ability, right, to change at will, right? We don't have to worry about, I changed something in this object, right, or in this class, and all of a sudden I have to change, other parts of my program because it was relying on it. No, it should be this black box, that you can't see into. Everything's self-contained, right? Nobody has any idea how the thing works, right? We're completely hiding that internal representation. Now, how does this, play into the idea of classes? Well, classes simply don't have any restrictions, okay? So Java lets you just do whatever, right? If you wanted to, you could just make everything in the class public, right? And that would be bad because everybody really can tinker with it. It's a horrible situation. They can tinker with everything instead of just, a few things. Okay. If in a class you make all of your data public, basically that means everybody can change your state directly. Usually what happens is that when you are first taught classes, you're taught, hey, make your state public, so make your state private, and then all your behavior is public, right? So it's like, well, your methods are public, your variables are private, right? And that gives you a little bit of abstraction because, people can only call those functions, but still everybody can call those functions whatever they want. And those functions could change the stuff inside. Classes just have so much flexibility there. For us, right, we really want to make sure that everything is self-contained, right? It's very much encapsulated, that everything is appropriately hidden. Overall, right, this kind of idea of an ADT that we've introduced is purely a design choice, right? So it's not enforced Java syntax. There's no keyword for me to use in Java. This is just me in terms of design. All right, so our final note here is about abstract classes. So abstract classes are things you guys have probably seen before. An abstract class is not an ADT, though. An abstract class is basically a class where not everything's been filled in. So typically when I have a class, it's like I'll have a bunch of different methods inside, and all those methods, there's some implementation for them available, right? And so it's like, well, if I create an object from that class, I'm good to go. I can call those functions, all the different code will run, life is good. For an abstract class, some of the methods inside of that class are not defined. They're actually just marked abstract, which means, someone needs to fill them in. And so I can't actually create objects from that class. Rather, I have to create child classes. Those child classes inherit that parent class, which is abstract, and the child is obligated to basically fill in the blank, right? They have to create their own methods, which basically are the implementation for the things that were marked as abstract in the parent. Because the parent isn't providing any implementation, it's purely up to the child to provide that implementation. So that's kind of a different view, right? So basically, an abstract class is an incomplete class, so we have to fill in some methods, right? And we do that via children. ADT is, again, just the idea of hiding internal representation as much as we possibly can.